Hypatia was an Egyptian woman, daughter of Theon, who was considered one of the most educated men in Egypt. She was raised by her father and became a scientist, mathematician, and philosopher. One of Hypatia's students credits her as the inventor of the astrolabe. She is mainly known to have contributed to conics in mathematics, which was first introduced by Apollonius. She edited the work on the conics of Apollonius, which divided cones into different parts by a plane. This concept developed the ideas of hyperbolas, parabolas, and ellipses. With Hypatia's work on this important book, she made the concepts easier to understand, making the work survive through many centuries. Hypatia was the first woman to have such a profound impact on the survival of early thought in mathematics. In 1962, at the age of 27, Gloria Hewitt was the third African-American woman to receive a PhD in mathematics. Hewitt received her degree from Fisk University. In 1961, just before the completion of her degree, Hewitt joined the faculty at the University of Montana. 11 years later, she received full professorship, and today, she is the chairman of the Department of Mathematical Sciences. She was also a reader and table leader for the grading of the AP Calculus exam for 12 years, and a member of the AP Calculus Test Development Committee from 1991 until 1995. Being one of the first African American women to receive a PhD in mathematics, you believe there was a lot of racial discrimination. However, Hewitt stated in a personal interview that she does not feel there has been any racial incidences in her career that have had a detrimental effect on her studies of mathematics. She goes on to say that some of her fellow graduate students did all they could to help and encourage her. They included her in most of their activities. She knows this situation was not the normal for a lot of blacks studying mathematics, but she was fortunate enough to be at the right place at the right time. Florence Nightingale was an English statistician and social reformer during the Victorian era. While better known for her contributions in the nursing and mathematical fields, Nightingale is also an important link in the study of English feminism. She collected data and systemized record-keeping practices. Nightingale was able to use the data as a tool for improving city and military hospitals. Nightingale's calculations of the mortality rate showed that with an improvement of sanitary methods, death would decrease. As Nightingale demonstrated, statistics provided an organized way of learning and led to improvements in medical and surgical practices. She also developed a model hospital statistical form for hospitals to collect and generate consistent data and statistics. She became a Fellow of the Royal Statistical Society in 1858 and an honorary member of the American Statistical Association in 1874. Carl Pearson acknowledged Nightingale as a prophetess in the development of applied statistics. She developed the polar area diagram to dramatize the needless deaths caused by unsanitary conditions and the need for reform. With her analysis, Florence Nightingale revolutionized the idea that social phenomena could be objectively measured and subjected to mathematical analysis. She was an innovator in the collection, tabulation, interpretation, and graphical display of descriptive statistics. Maria Gaetana Agnesi was exposed to mathematics from a very early age. By the age of 20, she had already started work on her most important contribution to mathematics. She wrote the book Analytical Institutions, which focused on differential and integral calculus. Originally, it was intended as a textbook for her brothers. However, it was eventually published in 1748 to wide acclaim and was later translated into English. Early sections contained elementary problems on maxima, minima, tangents, and inflection points. An cubic curve, now known as the Witch of Agnesi, was described by her text. The name came from a mistranslation of the original Italian that appeared in the English edition. Today, this curve is a common example found in many calculus textbooks. Sophia Germain never married and pursued her mathematical studies with what her recent biographers term limitless passion and devotion. She studied mathematics on her own, but her parents were very opposed to her studying at night. They responded by leaving her fire unlit and taking her candles. Sophie studied anyway, swaddled in blankets by the light of smuggled candles. On the establishment in 1795 of the École Polytechnique, which women could not attend, Germain befriended students and obtained their lecture notes. She submitted a memoir to the mathematician J. L. Lagrange under a male student's name. Lagrange saw talent in the work, sought out the author, and was bowled over to discover it had been written by a woman. After that, she continued to study, corresponding with leading mathematicians of the day. During this time, Napoleon authorized an extraordinary prize for the best mathematical explanation of the phenomenon of curious patterns produced on small glass plates covered with sand and played, as though the plates were violins, by using a bow. The sand moved until it reached the notes, and the array of patterns resulted from the playing of different notes. The Institut de France sponsored a competition with the challenge of formulating a mathematical theory of elastic surfaces for this phenomenon that Napoleon discovered. Most mathematicians didn't even bother to enter, believing the existing mathematical models were inadequate to solve the problem, but Germain spent the next 10 years attempting to solve it, submitting 3 separate papers, the only entrant in the competition all 3 years. She failed to win anything in her first 2 submissions, but on her third attempt, submitted around May 1816, the judges deemed her paper entitled Memoir of the Vibrations of Elastic Plates worthy of a prize, despite pointing out some remaining mathematical deficiencies. This paper became known as harmonic motion because it was the first scientifically visualization of 2-dimensional harmonic motion. Sofia Kovalevskaya was a Russian influential mathematician, writer, and advocate of women's rights in the 19th century. She claimed to have been introduced to differential and integral calculus at the age of 11 by studying her father's old calculus notes. After concluding her secondary schooling, Sofia was determined to continue her education at the university level. She went on to become the first woman to be granted a PhD in mathematics when she was awarded her doctorate from Göttingen University in 1874. In 1888, she entered her paper on the rotation of a solid body about a fixed point in a competition for the bricks brought by the French Academy of Science. She won this competition. Prior to Sofia Kovalevskaya's work, the only solutions to the motion of a rigid body about a fixed point had been developed for the 2 cases where the body is symmetric. In her paper, Sofia developed the theory for an unsymmetrical body where the center of its mass is not on an axis in the body. The paper was so highly regarded that the prize money was increased from 3,000 to 5,000 francs. Many colleges and universities in the United States now hold annual Sonia Kovalevskaya Math Days for high school girls to celebrate mathematics.